Welcome to part 2 of finding the domain. If you recall from last time, we went over this briefly. When there's a rational function, we don't want the denominator to equal 0. It can't equal 0, in fact. Everything else will be in the domain, but not that number or those numbers that make the denominator equal 0. And similarly, in a square root, we also have domain restrictions, and those restrictions are that the inside cannot be a negative value, okay? So we don't want negative numbers in the square roots, and we don't want zeros in the denominators, but in order to find the domain, we kind of have to figure out what those values are so we can exclude them. In the last video, we went over these A, B, and C problems here, which was a rational function, a square root, and then a square root with a quadratic inside of it. We'll do D and E in this video, which are basically rational functions and square roots combined. So we'll see how to deal with those. Out of all of it though, when it comes to finding the domain, these are the 5 different types of cases that you could run into. Now of course there's many different functions that have domain restrictions, but for now this is a good base of what you would need to know. You'll learn some more functions that we can find the domain on a little bit later. So let's get started with letter D. Okay, here is letter D of our 5 problems that we're covering. In this case, we have a rational function, and in the denominator itself, there's also a square root. So what we know from this is that the square root cannot, this thing down here cannot equal 0. At the same time, what's inside the square root cannot be negative. Now this one's a little easier than you may think. It's similar to what we would do when the square root is on top, or when the square root is by itself, I'm sorry. When the square root was by itself, remember we said this. We said this, and that was an example letter B, when the square root is by itself. However, because we're in the denominator, all we simply have to do is remove this equal to line, and we solve it the exact same way that we did when we just had a square root by itself. Subtract the 1, and if I divide by 3, I get x is greater than negative 1/3. Now please also keep in mind, I didn't mention this last time, remember that if I was dividing by a negative here, this sign would flip. But in this case, I did not do that, so the sign did not flip. So just make sure you have that in your toolbox so you know. But now that we've gotten to this part, let's look at this from an interval notation standpoint. What we're saying is everything from 1/3, from negative 1/3 and on, and bigger and larger, right? So x can be larger than negative 1/3, but it cannot equal 1/3. So the difference here from the other square root problem is this just simply does not get a bracket, okay? So this would be the domain here in interval notation. Negative 1/3 to infinity, and we're not including negative 1/3. So pretty straightforward. That's how you deal with it when there's a square root in a denominator. Now let's look at the final example where there's a square root in the numerator. All right, the final example here in finding the domain. In this example, we have a square root on the numerator, and we also have a rational function which has a denominator. Now this one can be the only one, I think, that's somewhat tricky sometimes. Sometimes you have to really think about this one once you've figured it out. But in this case, we need to figure out 2 separate domains almost, and then kind of use our minds to put it all together at the end. Let's look at the top. We know at the numerator there's a square root there. And what do we know about square roots? Well, the inside can't be negative. So we know that the x plus 4 needs to be greater than or equal to 0. Okay? Solving this out, well then x needs to be greater than or equal to negative 4. Let's keep this in mind as we continue. We also have a problem down here, which is the denominator cannot equal 0. So what we're saying now is that x minus 2 squared, we do not want this to equal 0. Well, the only thing that can make this equal 0 is if x equaled 2. So we do not want x to equal 2. Okay? So let's keep this in mind when we write out our domain. So here's the two things we know. We know that x needs to be greater than or equal to negative 4. And we also know that x cannot equal 2. So if we're to write our interval notation using this information, we will simply say, okay, well, we start at negative 4, and we can be anything larger than negative 4. However, we cannot be 2. So what this says is I can go from negative 4 to 2. I have to skip 2, and then I have to go on beyond that. That's kind of how this is being written here. Now you can see, hopefully, that there are cases where this could be tricky. You could have a number that the denominator can't equal, which is already excluded because of this domain. Okay? So let's just, as an example, I know this isn't right. Let's pretend this was 4 for a minute. Let's just pretend x needed to be greater than 4. Okay, I know that's not correct for this problem, but just to explain this, okay? If you get a problem where the numerator has to be greater than 4, well then if the denominator can't equal 2, well, you've already said that because you said that x had to be greater than 4. So you wouldn't have to even worry about including this negative 2 business in your answer. That's what I mean by sometimes you have to think a little bit. Or it could be that your x can't equal multiple different numbers. For example, negative 2 and 2, or it could be 2 and anything else. You have to kind of combine these two. Let's put this back to the correct thing. You have to combine these two to make sure that you're getting it exactly correct. All right? So this one out of all of them requires a little bit of thinking once you've done the actual mechanics of it. Solving the problem itself is not a difficult task. You're just following the rules of algebra. But for this one, to use this type of critical thinking to figure out exactly what the domain should be, you have to be able to see that. Okay? Thanks for watching this. Please stay tuned. There'll be more videos to come.